Welcome to our last video in this first unit on limits. This video focuses on continuity, and the reason we look at continuity so much is because we're going to look at derivatives in our next unit, and differentiability is a big idea with the AP folks. And so a function needs to be continuous to be differentiable at a particular point. So we'll keep on looking at this as we go forward. Now in this video what we're going to take a look at is we're going to take a look at where our functions are continuous, what types of discontinuity we might have, and then we're also going to take a look at the intermediate value theorem. Let me just say something about the intermediate value theorem. This oftentimes will end up on the AP exam as a particular, for you to justify something as true. I don't even do an example of this. It's kind of common sense. It just says that if a function is continuous, it can't go, for instance, from 0 up to 5 without going through 3. I mean, that's just kind of like, it is common sense. But intermediate value theorem just says that if it's going to be continuous, it's got to go through all values between 0 and 5 on its way. There are different types of discontinuity or different types of continuity. In this particular example, the first one, this is what we call a point or removable discontinuity. The point falls off the graph. The limit exists, the point exists, but they're not equal to each other. So the third part of the definition is disqualified. The second one is infinite discontinuity. You have this vertical asymptote at our critical number. In this one, our limit would not exist because as I approach this critical number c from the left, I go to positive infinity. From the right, I go to negative infinity. It does not exist. And then finally in this one, this is called jump discontinuity. And then jump discontinuity, again, the limit does not exist because as I approach this critical number c, from the left-hand side, I'm up here, and from the right-hand side, I'm down here, so the limit does not exist. There are three parts to the definition of continuity. First of all, f of x the equation must be defined at a critical number. In other words, the point has to exist. This limit has to exist, and then these must be the same. They must be the same. Okay. A couple of examples for you. In the first one, I have this piecewise function. We're looking at as f of x is this piecewise function. We want to know if it's continuous at 3 or not. So the first thing I'm going to try to do is I'm going to try to evaluate the limit as x approaches 3 of x squared minus 9 over x minus 3. Again, I got to do a little factoring. So x minus 3 times x plus 3 over x minus 3. And these will cancel, so that gets rid of my discontinuity at 3 for this particular part. So this converges to 6. So the limit is 6. F of 3 is 2 as defined in my piecewise equation. So the point exists, the limit exists, but these are not the same. So therefore, f of x is discontinuous. This has a point, what we call a point or removable discontinuity, because the limit exists, the point exists, but they're just not equal to each other. My second example, I have this equation, 2 over x squared minus 4, and we want to know is it continuous or not, or find all numbers or what domain values where is it going to be continuous. So what we know is that I can't have division by 0. So I set up, okay, x squared minus 4 equals 0. If I solve that, I get x equals 2 and negative 2. That's why I have vertical asymptotes. So this equation is going to be continuous on all real numbers except for x equals 2 or negative 2. A couple ways of writing that. I can write it as negative infinity to negative 2 union with negative 2 to 2 union with 2 to infinity. Or I can say it's all real numbers except x cannot be negative 2 and 2. The short answer question, obviously either one of these answers is fine. This one's probably a little simpler to write. If it's a multiple choice question, this is probably the way that we'll write the multiple choice questions. All right, we'll talk more about continuity in class. Good luck. See you soon.